Hello. In this session, we are going to discuss about operations on process. So, mainly, there are two operations that we are going to discuss here. How to create a process, that is process creation, and what about process termination. When the process is created, what will happen, and how it will enter into the terminated state. So now, the process creation, we can call a parent process and a child process. For example, if I'm having a process P1 and we know the system call used to create a new process in Unix is fork. If I, im- if I implement fork from P1, it create a new system call new process called P2. Here, the P2 is the child where P1 is the parent. So, parent is the creating process. The newly created process is called as child process. And we know that each process contains a process ID, unique ID. Now, this P2 can fork and create another child. It can be continued. P1 can create P2, P2 can create P3, and P3 can have two childs like that. It will keep on going. So, we can maintain a hierarchy of processes. Now, look at this. This is a tree of processes typically on a Linux based system. And in Linux based system, this is the core process. The OS takes a process, the kernel process. This is the kernel process with ID system D. Process name is system D. The PID is 1. That is the default, the kernel process identifier is 1. Initially, it was called as init. But nowadays, it's called a system D process. From this, when you look at this, you're having login ID process. This is used to create multiple users how they are entering. There is one user called bash and they are having the ID of 8416. They are having two programs are running, two processes are running. One is PS and PS is a command that is used to list all the files and VM is an editor, text editor. So there is one user who logged in with two different processes. Similarly, a Python process is here, a secure shell process is there, and like that we can have each process can create another process. Like that, the process created is actually it's like a tree of processes, and always the root node is the kernel process. It is the only one at the top. Now, when a child process is created, what is happening? There are three aspects we are going to discuss. When a child process is created, what about the resource shared between the process, parent process and the child process? And what about the execution? And what about the address space possibilities? Let us see one by one. First, the resource sharing. We know the resources may be CPU time or memory or shared files or IO devices. So, if a child process is newly created, what will happen? That is assumed here we are having one process P and it creates another process it's called child process. P is the parent process, C is the child process. There are two possibilities. A child process may obtain a resource directly from OS. So from OS it can either directly get all the resources or another property is that it will get subset of resources from the parent process. So two possibilities. Either it will take its standalone resources directly from the OS or it is constrained to use only the subset of resources that are already allocated for the parent process. This is about resource sharing. Next about execution. When a parent process creates a child process, it can there are two possibilities. Whether the parent will continue to concurrently execute along with the children or the parent can wait until all the children are terminated. That is, whether a parent process is created and it creates child 1, child 2, child 3, like that it has number of child process and either the four process can run in parallel P1, C1, C2, C3 along with the P. or the parent process will be in a waiting state until all the children completed and then P will resume his job. This is about execution. And next is the address space possibilities. That is how they are sharing the memory space. One thing is either the child process is the duplicate of the parent process. So I'm having a parent, I created a child process. The child process is the duplicate of parent process, that is becomes a B dash. It has the same program and same data as a parent. Whatever the task that is done by the parent is duplicated, that is the child process. Or other possibility is the child process has a new program loaded to it. The child is having a different job to take care of. So these are the three different possibilities. How a parent and child is going to be taken care of, resource sharing, execution, and address space possibilities. Now, before getting into in detail about process creation, let's recall few system calls: fork, wait, exec, and execl. We all know that fork is a new process. Fork is a system call to create a new process by duplicating the current process. That is, whatever the parent P is having, if I use the fork, it will make a P dash. That it will create a duplicate of the current process. Whatever the job allotted to the parent P will be replicated by the child P dash. This is the fork system call. And next one is the wait. Wait system call will make the parent process wait until the child process finishes execution. So if P is there and it creates the child P dash, and at that time when P is having the wait, then it will wait until P dash completes and informs the P. The parent is waiting for the child to complete its job. Next one, exec. Already we discussed that while we are creating a new process using fork system call, it creates a duplicate of the current process. But now, always I don't want to make the child process to do the exact operation what the parent process is doing. So what I need to do, I have to allocate a separate standalone job for the child process. At that time, I can use the execute system called exec. It replaces the current process with a new program. And you have to remember that it is not creating a new process, it transforms the current one by allocating with a new program. And when you take execl, it is a variant of exec. Same thing, whatever you are doing, it applies. It replaces the existing code. But how we have to specify the path and argument. That is, what are the routine, what are the job of the child process along with the list of arguments. So these are the basic system calls. Now let's see how we are going to create a process. So now we have taken first as the example, creating a separate process using the unique system call. So we know that fork is a system call that we will use to create a new process. So here, so we have to insert the header file sys types.head, and we are having the process ID data type to have the process identifier, which is the unique identifier for any process. Here, look at this. I'm using the PID equal to fork. That is, I am creating a new child process. Here, fork, what will it do? It will create the duplicate of the parent as it is. So now here, if the process ID is less than 0, that means there is a problem with the process creation. Now I use a fork system call to create a process. So what happened? I'm having a P as a parent process and I invoke the fork will create a child process. If PID is less than 0 means there is a problem in forking, that is creation of new process. It may be due to permission or due to me unavailability of memory space to allocate to a new process like that. That we will examine in detail later on. Now, if PID equal to 0, that means the fork returns two values. It returns 0 to the child process and it returns the process ID of the child process to the parent. So, based on the return value of the fork, we can distinguish which is a parent process and which is a child process because As of now, we are duplicating the parent process. So we should know which is the parent, which is the child. It's based on return type. If fork is equal to 0, it is a child process. If fork is greater than 0, it means a new process has been successfully created. And the return value is the process ID of the new process. So here, if PID equal to 0 means it's child process. Here inside that what I'm doing? I'm giving that execlp. I'm replacing the child process to do a new job. What is the task? I'm asking it to execute this command, ls command. We know what is the use of ls command? Yes, to list the files in the directories. These are the arguments I'm passing. What about the parent process meanwhile is doing? It invokes the wait system call. What is the meaning of wait? The parent will wait for the child to complete. Here, until the child completes his job, the parent is waiting. So once the child completes, it will return to the parent, then only the parent can terminate itself. So there is a dependency there. So in simple, fork is used to create a new process by making a duplicate of the existing parent process. Then we can use the execute system call or its variants to allocate a new task to the created process. And wait is a system call invoked in the parent side to make the parent to wait for the child to complete its job. This is what happening here. You look at this, there is a parent. When you use a PID equal to fork, if PID is greater than 0 means it is a parent here, and the parent is invoking the wait and it is waiting for the child process to complete its job. Meanwhile, what happened to the child? It uses the exe system call to allocate his new job, and when it exits, it returns to the parent's wait system call. Then the parent resumes his job. So when I use a wait in the parent job is paused or blocked until the child process completes its task. And this is the process creation of fork system call in Linux. Similarly, this is one example scenario how it is happening in the using Windows API. So you have to use the windows.h. So these are the basic C program structure that you are very familiar. And here, this is a major thing that what is the system call we are using? Create process. It is equivalent to fork. Fork is used in Unix. Create process used in Windows. Instead of wait, here we are having wait for single object. So it's the same program. It is in the Windows syntax. It is in the Linux C based. So you have to remember that wait equivalent is wait for single object and create process is equivalent to fork system call. This is how we are creating a new process in the Windows. So far we discussed about how to create a new process using fork and how to allocate a new task by using execute system call. Now the next one is the process termination. Of course, the process created and it is allocated to the new task. The task is completed, the process must be terminated. So what will happen? If I use the process termination, a process can be terminated when it finishes execution. How it is terminated? Using the exit system call. Here we discuss after completing, it will exit and return to the parent. And what it can do, it will return the status from the child to the parent using the wait system call. So the child can communicate to the parent process through the wait system call. And what will happen? The process resources are deallocated by the OS. That means if it holds one or two input output files or memory, those spaces are released to the OS. So the process that are the resources that are allocated to the process are revoked to the OS when the process is terminated. Now this is happen when a process terminates itself after successful completion of its job. Now let's see. There are some situations that a parent process may terminate the execution of the child process. Let us see when there is a need, a parent need to terminate the child process. First one, if the child has exceeded its usage and some of the resources that it has been allocated. If a parent may allocate 3 or 4 files to the child, But if child overrides their usage and it exceeds its limitation, the parent has the right to terminate the child. And next one, the task assigned to the child is no longer required. I don't want the child to perform the task. The requirement of the task is over. So I need to terminate the child. And next one is that the parent is exiting. When the parent is exiting, the OS never allows a child to continue if the parent terminates. So if the parent is going to terminate, it of course make it the child to terminate. So these are the different reasons why a parent process may need to terminate a child process. So, some operating systems do not allow a child to exist if a parent has terminated. So, what will happen? If a process terminates, then all its children must also be terminated. Children means children, grandchildren, all the hierarchy. We have the tree. All the hierarchy of children in every generation must be terminated. So, this is called cascading termination. A necessity of a parent process forces all other lower level process to terminate, cascading the levels. So it's called cascading termination. And the parent process may wait for the termination of a child process by using the wait system call that we discussed. By using the wait system call, a parent can wait for the child to terminate. If I want to know, and you may know that, for example, you are having a parent P1, the parent P1 may have C1, C2, C3. I'm having three different child process, and when this child process terminates by using the wait system call, by using this parameter of wait status, it returns the status of the terminated process and it returns the PID because there are three child process for this parent process P1. So if one process terminates, I should know the parent should able to track which child process has terminated. So the return type of the wait system call is the PID of the terminated process. Now it returns C3 and it gives a status. For example, one open file is closed, two files has been opened like that. What are the status of the child process? So the call return status information and the PID of the terminated process is communicated to the parent by using the wait system call. Now, there are some peculiar conditions. If no parent is waiting, then the process is called zombie process. That means a parent P is there, parent creates the child, but there is no wait. Parent keep on doing its job. This parent is not, it keep on doing the job. The parent is not depending on the child. Both are running differently. That's called zombie process. This is said to be zombie. It's neither communicated to the parent nor. So it's a separate thing. It's called zombie process. In another cases is that the parent process there and there is a child process and the parent terminated without invoking a wait. Then the child process is an orphan process. The parent terminated. It doesn't invoke a wait to know the status of the child. So if there is no parent, we can call it as called orphan process. So while termination of a process, we should know when there is a need for a parent to terminate the child. And termination of a parent may lead to a cascading termination of all its children, and the wait system call is used to pass the information of the status of the children and the PID of the child process to the parent process. And if the parent is not waiting, that means the wait is not invoked, it is called a zombie process. If the parent is terminated without wait, it is called as orphan process. Now, as an example, let us see what has happened in the Android. In the Android process, what are the importance of the hierarchy of maintaining different processes? We all know that we are having the mobile OS and we often have to terminate the process to acquire the memory because in your mobile phones we have only limited memory. So often we need to close the process that are unused. How? So they have categorized the process into five different processes in Android. foreground process, visible process, service process, background process, and empty process. First, let's understand what are these. So, foreground process. First one is a foreground process. So, that is the current process which is visible on the screen, which represent the application the user is currently interacting with. For example, in my mobile, now, for example, I am using the Google Map. I am looking for navigation to my home like that. I'm having a Google Map. So even I'm having lot of applications are running in my mobile at that time. Google Map is now currently visible on the screen. I'm currently interacting with the Google Map. So Google Map is called as a foreground process. Now next one is the visible process. In the visible process, again, a process that is not directly visible on the foreground, but it is performing an activity that the foreground process is referring to. Now, for example, at the same time while I'm using the Google Map, I'm getting a call. At that time, I'm unable attending the call, but still in the main screen, my application is Google Map is still visible. It takes on the UA. In the UA, Google Map is visible. So it is called visible process. Next one, service process. The service process is that which is similar to a background process, but it's performing an activity that is apparent to the user. I know what is happening in that. For example, I'm having my music player. My music is playing in the background. It need not to appear in the foreground screen always. It is in the background. It is a service. We're providing a service. The user is knowing about the activity, what is happening there. Next one is the background process. A background process is the process that may be performing an activity but is not apparent to the user. For example, I'm having my WhatsApp. I'm actively using the WhatsApp. Suddenly, I want to move on to the Insta. I'm checking my Insta. Now, WhatsApp becomes my background process and Insta becomes my foreground process. Both are running, but I am associated with the Insta is there. But WhatsApp is working on the activity. These activities are performing in the background. And last one is the empty process, the process that holds no active components associated with any application. For example, I am checking for space WhatsApp and Insta. Suddenly, I am opening my FB, but I'm not seeing any messages. I just close the FB suddenly. I keep on watching my WhatsApp and Insta. But what will happen? My OS will keep my FB in memory without any active task. Why it is keeping in memory even though you close the application? Just to speed up the relaunch. To have the relaunch of the application, those data is available in the memory, but it is not working actively. It's called as empty process. It holds no active components, but it is still in the memory. So now there are five different processes based on the working nature we are categorized in Android. Now the Android will begin terminating the processes that are least important. So from most to least important, and this is the most important foreground process, and this is the least important. So now, for example, if there is no memory space, what it will tell, it will terminate the empty process, then background process like that. The last one will come to the foreground process. For example, suddenly you may get a message, your battery is draining, your WhatsApp is not actively using. For optimized usage, close the WhatsApp because it senses that WhatsApp is running in my mobile for a long time as a background process. It's not needed. So it will terminate the process in that hierarchy. So for killing a process is not a random thing. So yeah, in Android, they have the separate hierarchy to take care of process termination. So far we discussed about process creation and process termination. Thank you.